So anyway, first, thanks for joining me today. Today we're going to talk about reviewing patient flows in Markov models. And the reason we do this is to validate that your model is working the way you expect it to work. I mean, we build models to try to mirror disease processes and as accurately as possible represent those diseases so we can do some numerical analysis of those disease problems. But if we don't represent disease correctly, then we don't get valid results out. So what this webinar is focused on is reviewing the patient flows within your Markov model, understand how the cohort is moving through the Markov model so you can compare that to what you know about the disease, and then also understand how cost and effectiveness are being accumulated as the cohort moves through the disease. And if you don't review those patient flows, you really can't have a lot of confidence that your model is doing what you thought it was. So this is a critical element of the model, and it's a mistake to go from building a model like this right to the disease, right to the treatment comparison without making sure that what happens out here is actually representative of the progression of the disease. So that's what we're looking at today. Now, once you understand the diseases or you're representing the disease correctly, then you go back and think about the decision. But you really shouldn't be thinking about the decision until you're certain that this is working as you designed it to be working. So notice I've muted all the microphones. Please use the chat for questions, and I'll get to them as I can. So just to start, we're going to start with this model. I already have it open, but just so you know, it is available to you in the project's view, along with a whole bunch of other example models. So if in your project's view, there's a bunch of example models. This is mine, you won't see that. And then inside healthcare, if you scroll down, you'll see this Markov conversion model. So you can do this all yourself, later today or next week or whenever you want on the same model. And we'll just use this as an example. But it's just a regular, standard, fairly simple Markov model with a decision, two strategies. The first strategy has a full Markov model, and the second strategy just has a clone of that Markov model. So we're reusing this entire Markov structure for the second strategy. But if I turned on numeric values, which I have turned off to make it easier to see this model, you'll see different parameters are fed into this strategy versus this one, so you won't get the same results, even though the flows are designed in a structural way to be exactly the same. But that's not really what we're focusing on. What we're focusing on is what happens within this Markov model, which would be the same as what's happening down here with just a few different values. So that's the model. Another thing about this model, it's set up as a cost effectiveness model. So we're going to be accumulating cost and effectiveness, and there are actually three additional outcomes that we can look at that just count certain events. So I've got cost that's going to be accumulated at the local cancer state, the metastasis state, and at this progression event. And then I'm also have counters to count progressions, to count deaths through this cause, and to count deaths through that cause. And that's really, I want to hide the numbers so you can see the model better, but that's where a value is accumulated. And utility is only accumulated at these two states. So now we can go in and start to look at the model and try to understand how patient flows and the accumulation of cost represent the disease process as we understand it. So to do that, what we do is we're in the analysis layout. So all of these toolbar items up here are related to analysis. And we're going to select the top Markov node. And I'm going to run this, the extended Markov cohort analysis report. It's also available from the menu, Markov cohort extended. Now there's 4 of these, but the extended one is the most verbose one. It has the most transparency and a presentation of all calculations. So that's the one I'm going to run. It takes just a minute to run. And what you end up with is this long report. Now to make a little bit more space, I'm going to hide this pane and I'm going to slide this over so you can see a little bit more. And now we'll start looking at the details. And you'll see it's broken down basically into kind of 3 sections. You have your cohort flow section here, Here, these two, the brown and the white and gray, here are your primary outcomes, cost and effectiveness. And then as I slide further to the right, I have my additional outcomes, the counters I was talking about earlier. But we'll move through those a little bit at a time. Okay, and the first thing I'm going to do, the default presentation is a summary for the whole cycle and the states. So it's a simpler presentation, but if I can expand these anywhere I want to see more information, and I'm just going to expand it right here, everything. That shows you everything in the model. Now you'll notice here, if I look at these transitions, these state transitions, those are the nodes in the model. So if I slide this over and split the screen a little bit, I'm going to try that one more time. Slide that over to the side. And I look at the model versus the transitions, see local cancer to survive or die. Well, here's local cancer to survive or die. And then if you survive, then there are more events: stay here, progress, or die. Those are represented here. So however complicated you make your Markov model in the design of the structure, that's how much you're going to see over here in the flows. There's an exact correlation. So what you're able to do with the report is follow your cohort as it moves through every node in the model. So let me slide this back over here to give us a little more space. And let's start with the first one. So we start with everyone in the local cancer node. Why do we start there? Because that was the initial probability here. Started everyone in local cancer. No one started in these states. And then I'm not going to do all these calculations, but if this came out of a table based on background mortality and age, and it calculates to 0.007, and what do we see here? 0.007 dying and the remainder surviving. And then what's my next calculation here? This is 15% and 2%. And I could go back to my variables and show you those, but just trust me, this is 15% and 2%. And here's my 15% of the 0.993, so 14.9%. And here's my 2% of the 0.993, which rounds to 2%, and that's where the flow is going. So if I wanted to validate this model is working correctly, I would manually calculate these expressions and then go into the model and make sure that that's where the cohort is moving. And that's what I've done right here. Although I didn't show you the variables themselves, I could, and I will. For example, my probability of local to Mets was 15% in the first strategy. That was 1. And my probability of local to dead was 2%. So that's where those values came from in terms of validating the 15% and the 2%. So that's the flow through the model, and that applies cycle after cycle after cycle. So if we look over here at who died, right? We had 2% die here. We had 0.007 or die here. And so that's how many we're gonna see down here in the dead state for the next cycle. So where these terminal nodes end the cycle, it's gonna pop them into the appropriate states, local cancer, metastases, and dead for the next cycle. And then we have progression on the next cycle. And you can follow this chain as far down as you want to make sure that everything's working. And you'll need to do that when you have probabilities that change with time. So for example, the probability of dying from background mortality is different every time. It's 7.007, and then it's going to be a little bit higher and a little bit higher as you go down. So you could calculate 15 years into the future, it should be this much. I multiply that to how many people are actually in this state, and I could validate that transition is being calculated appropriately. So that's following the cohort. But that's not good enough. We also need to make sure that we're calculating our values correctly. So let's look at that next. So the next thing we're going to look at is the accumulation of our primary outcomes, cost and effectiveness. And we'll focus on cost, but really the same calculations apply to every one of these outcomes. So we'll focus on the cost. Now, back in my model, the cost of the local cancer state is 20,000. I could go back and show you that variable, but I'm just going to move forward. So it's 20,000. It's half cycle corrected in the first cycle. That's why it's 10,000 here. But every cycle after that, you see it's always 20,000, 20,000, 20,000. We show this to you because these values are not always fixed. So you might have had a calculation or formula that represented the cost of the local cancer state, and this would give you the ability to see how that formula calculated. Now, since it's fixed, there's not a lot interesting to go there, to look at there. However, what is interesting is, here's the half cycle corrected 20,000. Well, everyone was in the local cancer state. So since everyone's in the local cancer state, you get the full 10,000. If we drop down to the second cycle, we're no longer half cycle corrected, so we have 20,000, and now we multiply that times the 0.824, and we end up with about 16,000. And if we go to the next cycle, we're down to 0.679, so we get a smaller amount of cost coming from the local cancer state. So what's basically happening is, as your cohort moves through the model, it's going to accumulate the amount of cost here based on the percentage of the cohort that's in that state, or the percentage of the cohort that's at this event. And that's how cohort analysis works, but we want you to be able to have the transparency within our reports to be able to validate that it's working as you expected. So now there are three different elements that contribute to cost. One of them is the local cancer state. The other is the metastasis state. Now, when there's nobody in the metastasis state, we get no cost from here. But when we get down here and we have a little bit less than 15% of the cohort in here, now we are starting to get cost from the metastasis state. And we also are getting a $1,000 cost from the progression. And that progression is here. This is where the $1,000 cost is accumulated. So when we get here, we have 0.149 of our cohort progress. We multiply that times 1,000, and we get approximately $149 coming from that. So there's three contributors to the cost, and they always contribute the cost that they can each contribute is based on the percentage of the cohort that reaches that node multiplied times the value that we entered into the model. That gives us the value accumulated. We sum that up into the cost by cycle, here, and further down, and then we have a cumulative cost as we move forward. And if we drop down all the way to the bottom of this report, we get a total cost accumulated by the entire Markov model of $397,000. 100,000 of it came from the local cancer state, 296,000 of it came from the metastasis state, and less than 1,000 came from the progression event. Here's the total. And you see the same kind of pattern for the other outcomes. So just looking at utility from the top, here's my half cycle corrected utility. Everyone's in the local cancer state. Now my non-half cycle corrected utility, not everyone's in the local cancer state, so I don't get the whole 0.95. But now I'm getting utility from the metastasis state. Follow that down to the bottom, and here's the total QALYs generated by the whole model. Every cycle, every node in the model, whether that's a state or event, that contributes to utility, and we get a total of 10.10. Now let me just check to see if there's any questions before I move forward. No questions so far, so I'll just continue. Now, these other outcomes that we have out here, these are just things that I wanted to add. I was just counting events. So since I'm counting progressions, it's just a 1, right? Because I just want to take the percentage and multiply by 1, and I get the percentage, which was 14.9% of my cohort progressed to metastases in the first cycle. 0.123 in the second cycle, and the cumulative goes up. And if I go down to the very bottom, I see that overall 81.8% of my cohort progressed from local cancer metastases, 10.9% died from local cancer, and 57.6% died from the metastases. Now, that's not the only cause of death. I did not count background mortality deaths, but I counted the 2 cancer-related deaths in this model. So once we do this, now we have the basis for where these values came from, and we've been able to follow our cohort and seen how the values accumulate in the model. And now I'm feeling comfortable with the 397,000 and the 10.1. And now I can go back here, and when I run my cost effectiveness analysis, which I'm going to run now, so now it's doing, when I run the cost effectiveness analysis, it's doing all the same calculations that were done here. It's just not showing me the details because I didn't ask for the details. But what I end up with, and you can't really tell here, so I'm going to go to the text report. Here's my 397,000. Here's my 10.1. And if I had run the Markov cohort analysis on the second strategy and went to the bottom, I'd see the 425,000 here, 10.95. Now I can do my decision analysis because I'm now comfortable that these values are correct, and I can rely on the incremental cost, incremental effectiveness, and the ICER as being accurate. Whereas if I had just jumped to this and had never reviewed this report, I would be making a big assumption that everything was working correctly, an assumption that I'm not willing to make before I start presenting my results to colleagues or industry groups or whoever. Certainly not before I'm going to submit it to an HTA authority. So that's basically the cohort reports, but I want to show you a few other things related to these cohort reports. The first being that we can also do this on microsimulation or patient simulation models. Now, that may seem a little strange because when you run a cohort model, this is really it's not just the way it's presented to you, it's the way that the model is calculated. When we run patients through the model, I'm just going to close a couple of these outputs. When we run patients through the model, we're not splitting the cohort up based on percentages. We're actually sending individual people through the model, and we get our average cost and effectiveness by adding up all the costs of all the people and then dividing by the number of people. And so we're arriving at it a totally different way. And for this particular model, there's really no reason to run individual patients through. There's no heterogeneity in this model. There's no event tracking in this model. So I'm only running microsimulation on this model to prove a point that these same reports are available to you. So I'm going to start by coming down here, and I'm going to check this box to run microsimulation, which is individual patients. And I'm going to run, let's say, 500, which is really not enough. If I wanted accurate results, I should really be running 5 or 10,000, maybe even more. But I just want this to finish. In fact, before I do that, I need to come in here and I need to turn on time reporting. So by turning on time reporting, that actually records every step and every node taken by every patient in the model. So I'm going to turn this on. In the interest of time, I'm only going to track cost and effectiveness. I'm going to skip the counters just so it'll run a little bit faster. Now when I run the patients through, it's going to record the movements of my patients through the model. Now I can let it go, and this will take a minute to run. And now patients are running through the model till they die. Then the next person runs through the model till he dies. And we're gathering up all the data at the mean level, and we're also recording all the individual movements of those patients through the model. So we just got to wait for it to finish, which shouldn't take too long. There it goes. Now it's done. And now I get my means close to 396 and 4, but I didn't really run enough patients for it to be totally accurate. So you just bear with me because I'm just trying to make it not take too long. And now if you're not used to running time reports, you'll see over here, this is where the time reports are. And I can look at the details of the individuals at the one patient at a time level or at the cohort level. Now, this is what we're really interested in related to what we've been covering today, but I just want to show you this first. This is individual patients. Same kind of format as what we had over here, except because it's one patient, there's only one way they could go. They can't take 3-4 paths. So this particular first person survived, progressed, now they're in metastases, they survived in metastases, and finally died in stage 6. If I look to the next person, different pathway. Next person, different. This person died quickly. And I can just keep looking at the individuals, but that's not really what we're here for. So I'm going to close this. And I'm going to go back to the output from the patient simulation, and I'm going to look at it at the cohort level. And now you see results that are very, very similar to what we saw before. Right? We started with everyone in the local cancer state, and then we split the cohort up exactly based on the probabilities. Now we start with everyone in the local cancer state, but when we look at progressions, we're basically saying 2 out of my 500 people died, and the rest of them didn't. So we're aggregating up the individual patient pathways into the cohort level to give you the same cohort flow visibility for a patient simulation model that you could always get for the cohort models. And I think To me, this is a very important development that came into the software over the past couple of years, because I think there's been a lot of resistance to running patient simulation models, which means some of the models are too simpler than they should be, that they're not handling all the complications of the disease as accurately as they could, because people really didn't like losing these reports and not being able to understand the flows in their models. So that's why we added that in the last couple of years, is these reports, so that you can feel comfortable that if a model really does require patience for heterogeneity or for event tracking, that you're able to do that without giving up some of the reporting that you might like. Now, I'm going to stop for a second and look for questions. So I see one question, and the question is, could you please explain again the conceptual difference between microsimulations and what we did in the first part, which is a cohort model? So sure, I'm happy to do that. So many models, you could even say most models, a cohort model is sufficient. What that means is you don't need to distinguish between one patient, two patient, 3% patient, four patient. There's no difference in the way that the disease is experienced for different patients, and we can treat the cohort as one big homogeneous cohort. But that's not always sufficient to capture the complexities of disease. There may be important elements of heterogeneity. For example, let's say men experience the disease differently from women, and you want to integrate into the gender impact into the model. Or maybe there's a different tumor type, and some tumor types are more aggressive and some are less aggressive. And so you may need heterogeneity into the model to really represent the disease more accurately. There's also different reasons for another good reason to run individual patients through, and that would be if events that occur can have long-standing impacts. So imagine a model where people have strokes. So if you have stroke, your costs should probably go up forever, your utility should probably go down forever, and your probabilities are going to be worse in terms of your outcomes. So if you don't use patient simulation model, all of a sudden you need a whole bunch more health states to say everything's worse if I've had a stroke, or everything's even worse if I've had 2 strokes or 3 strokes. And your model can get way out of control if you try to do that in a cohort model and don't instead record the number of strokes people have had and then use that to adjust probabilities, costs, and utilities appropriately. So that's a long version of the answer, but the shorter version of the answer is sometimes the complexities of the disease progression require you to store data at a patient level so that you can more accurately represent the disease, whether that's characteristics that the patients enter into the model or it's events that occur as the patients pass through the model. So I wish I could have answered that more quickly, but it's a complicated question. So this is the generation of the outcome from patient simulation data, and then there's one more thing I want to show you related to this model, and that has to do with converting the model to Excel. And that's another way to review the patient flows. And this takes a little while to run, so I'm going to start it up before I really talk about it. So I'm going to click on the decision node, and I'm going to run right here to run the convert to Excel. And what this is doing as it runs is it's basically recreating all the structural elements and all the input numeric elements and converting them all into an independent Markov model, or actually, in fact, 2 Markov models that run and exist in Excel. So there's no more need for that model to be connected to TreeAge Pro. So this is a nice thing that you can do if you want to share a model with someone who doesn't actually have TreeAge Pro, or potentially you're submitting to some organization that prefers Excel. So this will convert it. Now, I will warn you that there are a lot of advanced features in TreeAge Pro, and they're not all supported by the conversion process. For example, you cannot convert a simulation model. You can only convert cohort models. So it's complete. So I'm going to open it, and you see the name. I just need to enable the context because it has some macros that need to run. And here's our 397,000 and our 10.10 rounded. If it were rounded, it would be 10.1, and 425 and 10.95. And here's the same ICER that we got before, 32,653 back in TreeAge Pro. I could even validate that by just returning to TreeAge Pro. Let's go back to the text report. Oh, not that one. I got to rerun it. Sorry, I closed that report. I'm just rerunning the decision analysis 32653, and then back in Excel 32653. It's the same ICER. And in this case, now this is a completely independent model that doesn't need to go back to TreeAge Pro, and it includes the inputs. These are your variable parameters, and then here are all the calculations. This is the way that that cost, or excuse me, here's your cohort flows. Here's accumulation of cost. This is all for treatment one, effectiveness, etc. And then all the details are going to be out here. So now here, this is the same representation that you saw back in TreeAge Pro of all these flows, right? All these different nodes and the movements, and then the accumulation of cost and utility are now in Excel. Here's my movement of my cohort. Here's the accumulation of cost, of utility, and my counts. And if you really wanted to get into it, you could look at the formulas here, and you can see all the formulas that are generated independently in Excel. So that concludes what I wanted to cover today. But the important message that I want to leave you with is that when you build a Markov model, whether it's a microsimulation or a cohort model, you really need to study these flows in order to feel comfortable that what you've built in the model is representing your understanding of the disease accurately. And if you don't do that and jump right to the conclusions and the decision analysis, you really haven't done your due diligence in terms of understanding your own model and validating that it works correctly. So I'm just going to see if there are any questions that people have for today. It doesn't seem like there are any questions, so I'll just thank you all for joining me today. And again, we will be posting this and other past webinars. Not there. We'll be posting all those webinars on this webinar page, which you can get to. A shorter one is just www.treeage.com/webinars, and you'll get right here, and you'll see. This is. I know you've been here because you registered, and also we'll post the past ones down here in case you want to see them in the future. So again, thank you all for joining me, and I hope you'll join us for another webinar when we give one next month. Thank you very much, and goodbye.